Question 10, QP12, summer 2015. The equation of a curve is y is equal to 4 over 2x minus 1. Given that the line 2y is equal to x plus c is a normal to the curve, find the possible values of the constant c. So for the part of the problem, which focuses on what, according to the introduction, you saw, the application to tangents and normals. We just focus on the part. The first part, as you know, will also be showcased in the other portions of the video that will deal with integration and etc. So no qualms about that. Let's look at what it mentioned. So we were given the equation of the curve, right? The equation of the curve, as we know, was y is equal to 4 over 2x minus 1. That's the equation of the curve. Y is equal to 4x over 2. So y is equal to 4 over 2x minus 1. So this is the equation of the curve of the problem with. And we're saying that the line 2y equals to x plus c is a normal to the curve. And we want to find the possible values of the constant c. So this is the line, the normal. Is given by 2y is equal to x plus c. And we are saying that this is the normal to the curve. We want to find the possible values of the constant c. So guys, remember that when you have problems of this nature where you have the normal being spoken about in the same breath as the equation of the curve, the question is asked, what is the relation between the equation of the curve and the normal? Now, for one thing, the normal is the line that is perpendicular to the tangent. And for every tangent, the tangent is like the line that meets or that touches the curve at a particular point. And so the gradient of the normal is the negative reciprocal of the gradient of the tangent and vice versa, such that if you are given the equation of the curve and you're able to find the gradient of the tangent, the negative reciprocal of that should give you the gradient of the normal. So questions of this nature where you are asked or you hear the normal being mentioned, it's of utmost importance that you try to establish or find out what the gradient of the normal is. When you know the gradient of the normal, you try and use your understanding about the gradients of curves and tangents and try and set up a connection in there. Hope you are fine. All right, so let's see. What do we do? 1, the normal of the curve is 2y is equal to x plus c. Our goal is to find the gradient of the normal. Let's see how we go about that. So the normal is equal to 2y is equal to x plus c. Hence, we want to find the gradient, make y the subject. So you're going to have your y is equal to x over 2 plus c over 2. I hope that is clear. So in the form y is equal to mx plus c, you have y is equal to x over 2 plus c over 2. So clearly, the gradient of this normal is 1 over 2, because we know that the gradient is the coefficient of the x, okay? So the grad n, which stands for the gradient of the normal, is going to give you 1 over 2. All right, hence the gradient of the tangent, because remember the normal is the line that's perpendicular to the tangent. We need to then find the gradient of the tangent here. So gradient of tangent, okay, grad of tangent will be the negative reciprocal, which is going to give you what? Minus 2. Hope you are fine with that. Okay, so we're going to have minus 2 here. Now, so the gradient of the tangent is minus 2. What are we doing with the tangent now? Now remember that the gradient of the tangent will be the same as the gradient of the curve at the point where the tangent touches it. So we need to find the gradient of the curve. Now we know that y is equal to 4 over 2x minus 1 is the equation of the curve. So how do we find the gradient of the curve? dy dx. All right, so now we can say y is equal to 4. If we rewrite this, we're going to get 2x minus 1 to the power negative 1. Okay, so when you differentiate this, dy dx, what do you get for dy dx? You're going to have minus 4, as you know, okay? 2x minus 1 all squared times, you enter the bracket and you have that. Any problems with that? So when we try and put this together, okay, so we can say that our dy dx is going to give us minus 8 all over 2x minus 1 all squared. Hope you are clear. All right, so this dy dx, which is the gradient of the curve, can also be used to find the gradient of the tangent at that particular point that we are speaking about. Okay, so what then do we do here? What then do we do? All right, so we can say that the point of intersection, okay, at the point of intersection, the gradient of the tangent, or where the gradient of the tangent is equal to the gradient of the curve. All right, so we can have 1 over 2, okay, which is the gradient of the normal, times minus 8 over 2x minus 1 all squared, which is the gradient of the tangent, should give us negative 1. Hope you're okay. Gradient of the tangent and the gradient of that should be able to give us negative 1. So that is one way that you can solve for that. Okay, so you can first say that minus 8 all over 2x minus 1 all squared times the gradient of the normal should give you negative 1. Or, remember, once we've been able to estimate the gradient or find the gradient to be negative 2 here, we can just take the minus 8 over 2x minus 1 all squared and equate it to minus 2. Because remember, this is the gradient of the curve, which is the same as that of the tangent, then that one is also the same. So we can just equate that. Now, when you try and work that out, okay, when you try and work that out and get the algebra, you would get values of x being equal to minus half and x equal to 3 over 2. So I'm sure that you can just work out the algebra there and you get the respective values of x. So now that we know the values of x, what is going to be the values of y? Okay, because we know that y is equal to 4 over 2x minus 1. So what do we do? All right, so at x is equal to negative 1 over 2, what is going to be our y? We put x equal to minus 1 over 2 into the expression there, and we find the value of y. Now, when you do that, you are going to get your y, okay, to be minus 2, right? Y to be minus 2. And if that is the value of the y, you can equally find the value of your c. So for this set of values of x and y, your c is going to have a value of minus 7 over 2. Okay, so that should be easy for you to work out. You take your x equal to minus 1 over 2, y is equal to negative 2. You just come and slot them into this expression here to work out your c. And your c should give you minus 7 over 2. Okay? So we can find the other value of it. So we look at x, okay, equal to 3 over 2. What happens to your y? What happens to your y? You take your expression, y is equal to x 4 over 2x minus 1. You put that in there nicely. And your y, okay, and your y is going to give you, 2 there, okay? So when your x is equal to 3 over 2, your y is equal to 2. You can just work out and confirm that. So with x 3 over 2, y is equal to 2, what is going to be your c? You do a substitution into that, and your c should also give you 5 over 2 there, 5 over 2. You are fine. So the possible values of c that we will have when we have the normal being equal to 2x is equal to x plus c should be what we are seeing here. Minus 7 over 2, 5 over 2 in the case where your x is minus 1 over 2 and your x is 3 over 2 respectively. Question 10, QP13, summer 2015. Points A, 29 and B, 30 lie on the curve y equals to 9 plus 6x minus 3x squared, as shown in the diagram. The tangent at A intersects the x-axis at C. Showing all necessary working, I. Find the equation of the tangent AC and hence find the x-coordinate of C. Okay, so for question 10, as you saw in the diagram, which I've just attempted to reproduce a bit of it here for you, what you see how it looks like. All right, I'm sure it's just the same as what you've seen there. So let's look at the parts. As the question revealed, that you have A 2 9 and B 3 0 being on the curve, which has the equation 9 plus 6x minus 3x squared. And we are saying that this tangent also casts the x-axis at point C. That's what the problem tells us. And we are being asked to find the equation of the tangent AC. And hence, when we need to find the equation of the tangent AC, we should also be able to find the the x coordinate of C. So what do we do here? All right. Now, in this application, as you've already been told that here we are looking at the application of differentiation to differentiation in terms of tangents and normals. How does that work out there? The equation of a curve, okay, is the same as the equation of the tangent to a particular point on that curve. All right. So when you take the point A, 2, 9, since we are interested in finding the equation of the tangent AC, AC is a straight line, and for equations of straight line, you have to use a 1-point formula, where you just need 1 point and the gradient. So the key thing that is missing in this problem for us is to be able to find the gradient of the tangent AC. Once we find the gradient of the tangent AC, finding the equation of the tangent AC would not be a problem. Hope you're okay. All right, so how do we find the gradient of the tangent like AC? So we just need to find the equation like the gradient of the curve at the point. So we know that the curve is giving us y is equal to 9 plus 6x minus 3x squared. So like we know the rules. To find the gradient, what do? We take the first derivative. Okay, so dy dx is going to give us, that's going to go away. So we're going to have 6 minus 6x, right? We're going to have 6 minus 6x. So we want to look at point A, 2, 9, because that is where the tangent fits. So okay, so at A, where you have 2, 9, what is going to be the value of dy dx? What is going to be the value of dy dx at point A, 2, 9? So we just take the value of 2 and slot it in there. That's going to give us 6 minus 6 into bracket 2. So 6 minus 6 into bracket 2, when you resolve that, you're going to have minus 6. All right, so the gradient of the curve at point A is minus 6. And coincidentally, yes, that is also the gradient of the tangent at point A, which is 2, 9. So now we have the gradient of the tangent, and we have 1 point. We have the point 2, 9. Therefore, the equation of the straight line or the equation of the tangent can easily then be found. So what do? Equation of tangent. Equation of tangent, y minus y1 is equal to x, y minus y1. And remember, you're going to use the values in here. So you have y minus 9 equal to minus 6 into brackets x minus 2. So what happens there? When we're able to resolve that, you're going to have y is equal to, you're going to have y plus 6x is equal to 21. All right? Y plus 6x is equal to 21. So this is the equation of the tangent AC. And the question says that we should find the x coordinate at C. The x coordinate is on the x-axis. On the x-axis, y is equal to 0. So what do? All right, so at C, y is equal to 0. So we can say that our 6x is going to give us 21, and our x will be 21 all over 6. So that is going to be for the I part of question 10, QP13, that has an application to the tangents as we've just shown.